Today I'll be discussing the Lab 3 of the class Physics 2211 Section M, Black Hole, for the class Spring 2023. My name is Mopnal Mittal and I hope you guys enjoy this. The flow of the presentation will be kept quite simple as always. I'll first introduce what my experiment was. We'll be understanding the fundamental physics principle involved with this. We'll observe the motion of a given star, which was linked to our email ID and so very unique for each student. We'll then compare the computational result with our observation. We'll also understand what it means and what the motion of the rocket and the planet and the black hole around the black hole mean in terms of force and momentum. And at last, we'll discuss the what if scenario. The fundamental physics principles involved are quite simple. The first one is what we use to calculate the mass of the black hole, which is g m1 m2 upon r square, which is used to calculate the gravitational force between two objects, and thus we just play with the formula a little and calculate the mass. We also use the derivative form of the momentum principle, which is dp upon dt is equal to f net, and we define that in parallel and perpendicular components by using their respective formulas. Here's the video of my observation for the part 1. As you can see, the object is revolving around the black hole in an orbit. We'll soon be able to see our results for the same. As you can see, the mass of the object is given at the top, and then we have calculated f net using the glow script code and the two components f net parallel and f net perpendicular. Here's a link to my glow script code, and as well as I've used some chunks of my glow script code in the presentation itself. You can go ahead and visit my glow script code and read it. We have changed the mass and the delta t because it was given 1 and 1 in the initial thing. We've also calculated the mass of the black hole and printed it. And then here's the code to calculate the parallel and perpendicular forces on the star. Here are the results for the part 1. We have already seen this, but so I won't go over these again. Seen the results for part 1, I won't go over these. Here are the results for part 2. As we can see, the planet's orbital speed and the planet's orbital period, and how the spaceship doesn't crash, and how the spaceship doesn't crash inside with the black hole as well as the planet. As I've depicted here, the planet is orbiting, but the spaceship just goes around the black hole as well as the planet. What does it mean? According to the momentum principle, we have used the dp upon dt. This means that both are the same in magnitude and direction. Parallel and perpendicular components are also the same. We get the net force by adding up all the forces affecting the motion of the stars. We get the momentum by analyzing the motion of the stars. Here's the what if situation. In this, as you can clearly see, I changed the time from 2 hours to 5 hours. And so we could calculate the speed of the ship in x direction as well as the y direction. It's clearly visible that the ship completed a full orbit around the black hole. Thank you so much for listening to my presentation so carefully. Have a good day.